Okay, I'm going to move on to looking at some of the physicochemical drivers of the health of the bay. And one of those ones that I want to focus on, particularly this year in this presentation, is water temperature. Now, many people sort of, why are you interested in water temperature? Isn't that quite an arbitrary thing? Temperature goes up, temperature goes down. But for me, it is a very interesting aspect, and we've been monitoring water temperature at a site here in Small Bay called North Buoy carefully since 2014 through to the present day with the Saldanha Water Quality Trust. And we have a what we call a thermistor array. It's a set of temperature measuring instruments that are arranged on a string from the bottom. We've got one instrument at 12 meters just off the bottom. Next one a little bit higher up, 9.5, 7, 4.5, and then a final instrument just below the surface at 2 meters. And what is very fascinating about this is how the variation in temperature at different depths is so widely different. So these are the data from those various instruments. The line at the top, the colors are a little bit difficult to distinguish here, but the line at the top is kind of purple, turquoise, and that is from the temperature instrument, the highest in the water column, and the lines, the sort of light blue at the bottom there, comes from the one at the bottom, and the other colors, the green, the red, the purple, are all the ones in between. And what you can see, each kind of bump you see here is a year's worth of monitoring data. There's a lot of noise in this data, but what is for me very interesting is that there's a very marked difference between water temperature at the surface, which gets up to 20, 21 degrees Celsius, quite balmy, compared to what's going on at the bottom, where it's around 8 or 10 degrees Celsius. So very often there's more than a 10 degrees Celsius difference between what's happening at the surface versus what's happening at the bottom. And that's a combination of a process called upwelling and then solar warming. So solar heating at the surface warms the surface water up, gets to a nice balmy 22 degrees, whereas at the bottom here is mostly driven by a process known as upwelling. And during summer off the west coast, we get very strong southeasterly or southerly winds, tends to drive surface water up northwards, which quickly gets advected offshore. So those surface waters moving offshore gets replaced by deep water coming up from offshore, coming up wells next to the coast, process called upwelling. Some of you may be familiar with that. That upwelled water is icy cold. So during the summer, we've got an unusual situation on the west coast here where, although the atmospheric temperature may be warmer in summer, the sea is typically colder in summer than it is in winter, and we typically see temperatures around 10, 12 degrees along the coastline in summer versus the sort of 18 to 20 degrees that sometimes we see in winter. What the bottom graph here shows is the difference between the summer and the winter temperatures. Between the surface and the bottom water temperatures at across through that 7 year period. And what you can see here is the difference peaks in summer here. There's a 10 to 12 degrees Celsius difference between the surface and the bottom water temperatures in summer, which drops down to a less than 1 degree difference in winter. And that marked difference in summer is driven by upwelling. Cold, deep water is welling up, pushing into the bay during summer, comes in along the bottom and tends to sit there. Surface waters are warm, and what happens is we get very severe stratification in the water column in the bay, with warm water sitting on the top. Because it's warm, it's less dense. It tends to float on top of that cooler water below, and we get very extensive stratification with as much as a 10 or 12 degrees difference between the top and the bottom. And you can see that very clearly in the bottom graph there. What happens in winter when you see the bottom surface and the bottom water temperatures become much more similar? That's because southeasterly winds or southerly winds tend to calm down in winter, less upwelling. We get much more wave action. We get cold fronts coming through, stir up the water column, and the whole water column tends to become homogeneous with the same temperature at the top and the bottom. What's very important about this is this cold upwelled water that comes into the bay during the summer is very low in oxygen. It's coming from deep down offshore, welling up into the bay. It comes into the bay as oxygen deficient water. And because of the stratification that happens, because the warm water is floating on the top, the cool water is sitting down, that low oxygen cool water is sitting on the bottom, that bottom water doesn't get an opportunity to be exposed to the atmosphere, so it means that the oxygen tends to remain low in that bottom water, and in fact, because of the organic inputs we put into the bay, you get decomposition in those bottom waters, and the oxygen often tends to even go even lower in the bay. So we've got some really interesting data to go with the temperature data on oxygen levels in the bay through the ADZ monitoring program, the Aquaculture Development Zone monitoring program, which is being run by the Department of Agriculture and Forestry and Fisheries. We've got 4 oxygen monitoring stations in Saldanha Bay. We've got 2 in Small Bay, one which is away from the influence of any of the aquaculture, mussel rafts, oyster rafts, and then one which is moored right in amongst the rafts in Small Bay. And then similarly in Big Bay, we've got what we call a control station away from the aquaculture rafts, and one which is right amongst the aquaculture rafts. Now, one of the biggest concerns we have with aquaculture development in the bay is the potential impact this is going to have on oxygen levels in the bay. We know that oxygen levels are very low through much of the summer, and we're concerned about the impacts. The mariculture development will have on the bay. This is oxygen data from the last year from those 4 sites. So on the left here, on the top row is Big Bay, on the bottom row is Small Bay. Up here, when we talk about oxygen levels, the vertical axis here is different levels of oxygen in the water column in milliliters per liter, and we divide it into 3 levels. We talk about oxic conditions, which is the blue shading there, is anything above 4 milliliters per liter. We consider that well oxygenated, lots of oxygen in the water, great for fish, for birds, for marine mammals, any kind of marine organism. As long as oxygen levels are above 4 milliliters per liter, conditions are really peachy. A little bit lower than that, between 4 and 2 milliliters per liter, we talk about hypoxic conditions. Oxygen is now becoming depleted, maybe a little bit stressful for some organisms. In fact, it's a little bit stressful for most organisms. It's like being on top of Mount Everest. You're not getting quite enough oxygen, you're struggling to breathe, and you're struggling a bit. And then below 2 milliliters per liter, we consider that conditions are anoxic. There's just not really enough oxygen there to sustain life. That's when you put on your artificial oxygen or start breathing artificial oxygen on top of Mount Everest. Can't survive there for very long. If you're on top of Mount Everest without oxygen for more than 4 to 6 hours, chances are you coming off there are pretty slim. So this is the same situation here. And if we look at oxygen conditions, this is the control site in Big Bay, and from May through to May in 2019 May last year through to May this year, you'll see how the oxygen levels in winter, June, July, August, oxygen levels are well oxygenated. That's when the water column is turning over. The whole water column is completely well mixed. It's well oxygenated. All of the water is having an opportunity to be exposed to the atmosphere. Oxygen is dissolving into the water from the atmosphere, and we're comfortably in this oxic zone here. But as we move into spring, we start increasing, the southerly winds start increasing, and we're starting to develop stratification in the bay where the cold water is starting to sit on the bottom. That cold water is coming in from offshore. It's low in oxygen, and oxygen levels start to decline. By the time we get to mid-late summer, February, March, we're down to levels of pretty much anoxia, below 2 milliliters per liter, very stressful for most organisms. And then as we move into the winter again, oxygen levels go up. That's a completely natural process. This upwelling process, low oxygen water moving in the bay. Most of the organisms, most of the fish that are living in the bay are used to that. They tend to move up into the surface waters during summer when those oxygen levels are low. Maybe they move offshore out of the bay where they can get access to more better oxygenated conditions. And if we compare the sort of natural cycle between Big Bay, between the what we call the control station away from the mariculture rafts versus the impact station, which is where all the mariculture rafts are located, you can see there's hardly any difference between those two areas. There's very little area of concern there. If we look at Small Bay, the first thing you can see very quickly is that oxygen levels in Small Bay never quite get it up to the same level as they do in Big Bay. The amount of time that Small Bay is in that oxic state is actually quite low, even during winter. Even in winter, it mostly stays in that hypoxic state. This is the control site in Small Bay. So we're away from the mariculture rafts. In peak of winter, we're mostly in the sort of 3 to 4 milliliters per liter range. In summer, we're dropping down into this anoxic condition already in December, remains in that anoxic state for at least almost 5, nearly 6 months of the year, quite different to what's going on in Big Bay, and but starts climbing up again as we move into winter the next year. This is the Small Bay farm site. This is where closer to the mariculture rafts in Small Bay, and you can see much more variable, and unfortunately that is indicative of it being a much shallower site. This station is at 7 meters depth versus 12 meters depth, but on the whole, levels of oxygen here are quite a bit lower. They spend much more time in this anoxic state here than they ought to be for a station at that depth. So what it's saying to us is that, yes, the mariculture operations are having an impact on oxygen levels in the bay, and we need to be careful, and that is one of the main reasons why we didn't see any expansion in mariculture activity in Small Bay, is because of our concerns around oxygen. Most of the ADZ expansions are all happening in Big Bay, in Outer Bay, because Small Bay can't really accommodate much more organic input, which is impacting on oxygen. Just to put that in perspective, from a historical perspective, we've got some data from around 99, 2000. It's about just over 20 years ago. This is from Small Bay, similar location to where the data I showed you now. You can see there that the pattern is very similar. This is winter time over there, small period of time when Small Bay is comfortably oxic. Most of the time it's in this hypoxic state, and then, but again, quite a little bit of time in the anoxic state during summer. And so that tells me that not much has changed in the last 20 years. We've had a mariculture industry in Saldan and Small Bay for at least 20 years. We've been discharging waste effluent into Small Bay for a very long time, and conditions haven't changed much. If we wind back a bit further, we've got some much more spotty oxygen data going back to the 1970s when the port was first constructed. And we can see there, this data is present a slightly different set of data. It's in the form of apparent oxygen utilization. And all that says is if in the blue bars suggest that there's oxygen surplus in the water column. So there's more oxygen available in the water column than is required to decompose all of the organic matter that's present there. When it's in the red state, like those little bars there, it means that the amount of oxygen in the water is not sufficient to decompose all of the organic matter that exists there. And if you look, this is Small Bay at the top there, Big Bay at the bottom. If I just focus on Big Bay at first, you see that classic seasonal cycling between summer, when there's an oxygen deficit in Big Bay, and winter, where there's an oxygen surplus. And you see that seasonal sort of cycling going all the way through. This data is from 1974 to 1998. Not much has changed in that period in Big Bay. But if we look at Small Bay, yes, natural cycling up until about the early 80s. And we see quite an abrupt change there, where the apparent utilization goes into severe deficit in Small Bay around the 1980s and beyond. So a little bit concerned. We are very concerned about oxygen levels in Small Bay at the moment. We're just going forward through the data we're seeing here now. So we need to be careful about the volumes of wastewater we discharge into Small Bay. It's mainly because the change in oxygen levels in Small Bay was mostly driven by the construction of the ore terminal and the causeway linking Marcus Island to the mainland means that the exchange of water, the current exchange of water between the bay and outside is being much reduced. So any organic matter, any effluent we put into Small Bay tends to stay there, uses up the available oxygen, and we get to the situation where we've got an oxygen deficit in that area. And that's very bad for marine life in the area, and we need to be quite careful of that. The other thing that we look at quite carefully from a water quality perspective in Saldanha Bay are fecal coliforms. These are indicators of fecal pollution in the bay. So remember, we're discharging wastewater treated sewage effluent from wastewater treatment works in Saldanha and in Langebaan into the bay. Also, there's some fecal matter that comes down with stormwater into the bay, and it's used as an indicator of the suitability of the bay for contact recreation, swimming, canoeing, kayaking, sailing, whatever. And we've got a series of monitoring stations that are monitored every 2 weeks throughout the year. In Small Bay, there's a whole collection of stations there. There's 10 monitoring stations in Small Bay. Historically, we're monitored every 2 weeks. We've now gone on to a monthly monitoring cycle, but water samples are collected from each of those sites, taken to the lab to be analyzed for fecal coliforms, so we can understand that what risk there is associated with bathing at those locations. Those are the Small Bay stations, 4 stations in Big Bay, those colors in yellow there, and then a whole lot of stations in Langebaan Lagoon, the blue stations there. Just to for those of you not familiar with Langebaan Lagoon, it's a marine protected area. It's zoned into different areas. Zone A is what's considered multi-purpose recreational use area. All forms of recreation are encouraged, including motorized motorboats, motorized vessels allowed in this area. Zone B, kind of slightly enhanced conservation, no motorized boats allowed here. And then Zone C is a complete sanctuary zone where there's no boating activity allowed at all. So most of our monitoring stations in the lagoon are in Zone A, where most of the recreation takes place, but some in Zone B as well, where there is limited recreation. Going back to this table in the background there, this is data from the various monitoring stations that have been collected by the Water Quality Trust in collaboration with the Saldanha Bay Municipality from 1999 up to the present day. These are the 20 stations I spoke about: Small Bay, Big Bay, and Langebaan Lagoon. And each station, based on the year's worth of data we collect, we rate each station as being in excellent condition. In other words, completely safe for people to recreate in, to swim, to do whatever contact recreation you want to do, through to good, which is still perfectly safe, fair, maybe you should be careful, and poor, probably not safe for recreation. And what you can see there very clearly is back in the 1990s through to around 2005, conditions in Small Bay, or at many of the sites in Small Bay, were not really safe for contact recreation. Big Bay, much less development there, much better water exchange, always been reasonably good. And Langebaan Lagoon as well, all the way through fairly good. We had, through the pressure, through these monitoring efforts, it was brought to the attention of the authorities, we have a problem in Small Bay, and the Saldanha Bay Municipality put a big effort in to upgrade the wastewater treatment works, to upgrade pump station infrastructure. We saw quite a dramatic improvement in conditions around 2006, and there's continued continual investment in infrastructure to try and improve conditions in Small Bay. But as you saw from the volume of wastewater that's being discharged there, continually going up. It's continual race to try and keep conditions in this area as good as possible. Right now in 2021, conditions in Small Bay, there are still 2 sites where conditions are quite poor. One is opposite, both of them are, the one is in Hoochie's Bay, right in the corner of Small Bay. Is a little area of a little bit of concern. We think that's mostly affected by stormwater discharge from the town area flowing down into the bay in the corner. And the other is at the mouth of the Bok River, where where most of the wastewater from the Saldanha wastewater treatment works comes out, whereas most of the other stations are in reasonably good condition. In respect of Langebaan Lagoon and Big Bay, we were actually quite pleased to be able to say that all of the sites in those areas are in excellent condition for the data from the last year. So 100% suitable for contact recreation, and really, really nice outcome. It's probably, I think it's the only time in the full monitoring record where we've had a full suite of excellent results for those sites. So really nice, positive result there, and huge improvement. The other thing that we try and look at is levels of trace metals in seawater, well, not in seawater in the bay. Measuring trace metals in seawater is very difficult. The concentrations tend to be very low. What we tend to do is measure concentrations of trace metals in certain marine organisms. So organisms like oysters and mussels tend to pick up trace metals from the water column just through their natural filter feeding function and through the food they absorb, and they tend to concentrate these trace metals in their tissues, and in some cases they can concentrate them to levels where they can become a risk of heavy metal pollution to people that eat those organisms. And here I've got data on just 3 trace metals from a number of sites in Small Bay, so you can see the little map in the background there is Small Bay. There are 5 monitoring stations that we focus on in monitoring trace metal levels in mussels that we collect from the shoreline in Small Bay. And I've got data for lead, zinc, and manganese here. These data go back to the 1980s through to the present day. I'm sorry you can't really read the numbers. Each bar is a measurement per year over that period from the 1980s towards the present. The red dotted line there is the recommended maximum safe level of that particular contaminant in that seafood. So what it says is you probably shouldn't be eating foodstuffs with levels of lead that are higher than 1.5 milligrams per kilogram. And what is immediately clear is that in the past, concentrations of lead in mussels in many areas around Small Bay were way in excess of those safe limits. Things have definitely improved in the recent years. In most of these sites, you can see that for the most part, numbers or levels of lead in these areas are now, for the most part, below levels of concern. And I think that's partly thanks to removal of lead from petrol. In the old days, we used to have lead in the petrol. Now we've only got unleaded petrol. The one station that does remain of a concern is this little one in the corner here. You can see that the levels are currently below the thresholds of concern, but were very, very high in the old days. And that was probably, or at least partly, due to export of lead ore from the multi-purpose terminal. But again, practices have improved dramatically there. A lot of effort has been put into limit or to eliminate spillage of lead during that export process, containment of stormwater from the multi-purpose terminal, and you can see there, at least in the last 2 years, lead levels in those mussels are much better than they were in the past. Zinc, I mentioned dramatic increase in the export volumes of zinc in recent years, and interestingly, not translated through into mussels in the area. In fact, zinc levels in the mussels have been going down at almost all stations in the bay. So it suggests that it is possible, and it's easy to export those ore products without any risk to the environment, as long as appropriate precautions are taken. Manganese, slightly different there. As I said, manganese export has been started in earnest about 5 years ago in the bay, and we can see that levels of manganese are increasing at many sites in the bay. You can see those numbers going up, maybe not in the last year. Manganese is quite an innocuous substance. It's not really toxic. Well, it isn't manganese in food stuff isn't particularly toxic. It's not great if you breathe manganese dust in, but there are actually no defined maximum levels for manganese in food stuff. So we're not particularly worried about manganese. It's just something we're keeping an eye on to make sure that conditions don't change for the worst with this. So from a health perspective, quite pleased. Things are looking quite good from a trace metal perspective or trace metals in the water column. This is some data on trace metals in mussels, farmed mussels in the bay and farmed oysters in the bay. So now these ones are collected from the rafts, from the long lines, which are further from the shore. And very interestingly, conditions tend to be much better out there. Those mussels are not exposed to the same levels of contaminants that the ones are on the shoreline are, and levels tend to be much better. So for the most part, what you're getting in the local restaurants or restaurants elsewhere in the country come from these farmed mussels and oysters, and they are much better. Levels of trace metals are much lower here, and definitely not of concern, which is encouraging. But again, it's the sort of things that we need to keep our eye on to make sure that there is no issue for people eating organisms from the bay.